Hey guys, it's Monday, 12:50 a.m. on October 15th, 2018, and I have been going through a bunch of these videos tonight on these hurricane chaser dudes that go out there and film these storms. And I've noticed a handful of clips that just show me some red flags in terms of what are more telltale signs that this is just definitely not a typical hurricane. But not only that, but there are electromagnetic signatures all over this. So I want to play for you a couple of things. First, let me just tell you what I'm looking at here. In this particular clip, what we're going to see are the way the trees are moving. They're not going to be like you would normally see in a hurricane, where the trees are all bent in one direction, and in a sustained wind, tropical storm, or hurricane, they stay in that position because the winds are literally, by definition, sustained. They don't blow. They don't gust over and pop back up and bump over and pop back up with the shrubs jumping around. But in this particular video, although the winds are strong, unless you're actually looking to see how many different currents there are in this atmosphere, you might miss the fact that these trees are really swirling around and bending over and popping up, and the shrubs are dancing. There's a whole bunch of different currents happening in this atmosphere. So let me just play this for you. It's a short clip. See that? They bend over and they pop back up, and there's a lot of pulsing. This clip does an even better job of showing it, and what I'll point out in this clip is that as this camera pans over to the right, you're going to see a whole gust pushes these trees down, and as they spring back up, they seem to start swirling in different directions. Some of them will stay down longer. There are a bunch of different gusts and forces acting on these trees right here. See, there they all go down, and then they pop back up and start swirling around in different directions. Yeah, so I'll just play this one more time for you so you see what I'm talking about. And the point is that if this were a tropical storm or a hurricane, you wouldn't have such random forced gusts that push the tree down and push it back up. There's just a whole bunch of energy swirling in this atmosphere that I think is going to be best explained by this video here. And once again, I will reiterate that if you look at this freeze frame here of this thing, you see these are all palm trees that were probably planted around the same time. They appear to have palms that are about the same length, and yet look at in this particular one, the palm tree is arched all the way down, and then on this one, it's popping back up. It's almost as if the wind that is blowing here is going in a circle. It's like it's coming down from the ground and blowing up, and it's a whole bunch of different circles. But instead of circulating from above, it's actually circulating from the bottom up. In other words, instead of circulating, you know, from east to west around in a circle, it's like it's coming from bottom to top over and over again, which it's very strange. So let's take a peek at this one. See that as much as these palm trees are popping down, they're also popping back up. See how they want to pop back up? It's like they're opening their arms and swinging. Now, as this camera pans over to the left, what I want you to pay attention to, and if you've ever had an MRI before, you will recognize this crackle sound. But I want to point out that this is one of those cameras that does an auto light focus, where you will have your light sensor in your camera will automatically adjust to bring the camera, the image in view, whatever it's filming. And those light sensors are not very refined in terms of they can't distinguish between electromagnetic frequencies and light. So if you have a strong impulse of electromagnetic frequency pulsing through the atmosphere at the very time you're trying to take a picture, you won't get a very good picture. It's the light sensor is not able to discern between an EMF pulse and an actual light adjustment. Its photosensors won't be able to tell the difference on some cameras. And then this is one of those cameras. And what you're going to see here is literally every 15 seconds, in about 45 seconds, every 15 seconds you're going to be getting a pulse, and it's going to be visible, and you'll hear the crackling of the EMFs as they're actually in the atmosphere. So let's take a look here. You should be able to see that this camera is having a hard time maintaining its light focus. And if it's not clear yet, it will be in a second. You'll also hear that crackling sound. The more the pulsing happens in this atmosphere, the more the crackling sound will happen. And I want you to notice these trees blow up as much as they blow down and back. This is as far away from a tropical storm hurricane as you can get. The winds are blowing in every single direction. There is a myriad of frequencies happening and currents blowing through this atmosphere right now. In a couple of seconds, you're going to find out that they're not all wind. All right, now just to make sure that you catch this, I'm going to pause this and I'm going to put it on 75% speed, so you'll be able to catch this and take a look and see what I'm seeing here. All right, keep an eye on the light sensitivity of the camera here. See that? I don't know if you just saw that. Let me just back this up a little bit, because you're going to hear the crackling on the microphone increase like the sounds you would get in an MRI, quite literally. And then this corner here of the screen is going to start almost pulsing what would appear to be a light, but we know it's not a light because this is all cloud and darkness here. But the camera is responding as if it's light, and I'm proposing to you and basically flat out saying these are EMFs that are being pummeled through the atmosphere at this very time. So let's keep an eye on this. Let's watch. Hear that crackling? Now here come the lights. You can see the upper left-hand corner of the screen gets brighter. See that? And you can hear the crackling. Now watch the tree as it responds to the crackling and the lights that are going to come in. See this? Watch this. Hear that crackling? Get ready. Here it comes. Boom. Did you see that? How about that? Now this is happening like in every seven seconds, every 8. It's hard to tell. Like it seems like it's about every 7 to 8 seconds. Watch this again. It's building up. Now watch this as it hits 11:17. The whole upper sky is going to open up in like just this blast. See that? It's like a huge blast, and the tree totally responds. See that? It's like 2 blasts right in a row. I'll do it one more time. Here it comes. There's 1, 2 right now. And then the third one's going to be right about now. See that? Look at that. And this whole tree trunk just kind of, especially this part of the trunk, just blasts like it's been hit by lightning, but there's no lightning there. This is not lightning. I don't even think these guys could see this, and it happens so fast. I bet you they're responding to the flush of energy and the currents that they're feeling, but they would have no way of knowing that this is electromagnetic frequencies just by standing there. Plus, they're adrenaline junkies. They're not going to be that discerning. Okay, now let's just watch this. Do it one more time. See, that's just electromagnetic frequency ripping through there. That's not lightning. Those guys probably didn't even see that. And there are more. Look at that. Look at that. That's literally being shot at them from the sky. Another thing I want to point out here is, see all this debris floating around? Those are tree leaves. The terrible thing about this, you guys, is that these trees look like hell afterwards. I mean, they've been stripped of their bark. They've lost all their trees. They've been deplumed. And that is not what happens in a hurricane. Hurricanes do not deplume trees. But electromagnetic frequencies definitely do. And you can literally see the difference in this particular video clip where I'm showing you that they are being nailed by EMFs. That a majority of what's blowing through the atmosphere here are the freaking leaves that are quite literally coming off of this tree as they are being pummeled by EMFs. Let's watch this one more time. I'm going to back it up just a little bit so you can see what I'm talking about. I'll do it right about here. Watch this. See that? I mean, that tree just totally reacts to it, and look at all the stuff flying off of that tree. I mean, that's just shocking to me. That it's like a ray gun hits this place. And look at the tree. The tree just totally responds to it. Look at that. The tree's just getting torn apart by this. Here comes another one. Look at that. Look at that. And I mean, and here's the thing. It just pushes that tree all the way down when that EMF hits. Watch this. You can see the EMF hits this thing, and it just pushes that tree. Look how far down that tree goes. It just zaps it right down. Look at that. Boom! That thing just goes bending all the way. I mean, it's just terrible. But these are definitely strikes. I mean, if that was just, look, if that was just some weird light anomaly, you guys, the tree would not have bent over at the exact same time, okay? So what we're looking at here is definitely not your typical rainstorm. This is not some water drops that are happening on the lens. This actually matches the very moment that the atmosphere is reacting as if huge currents are being pummeled through it. So I'll just show you this one more time. The one here, it's at 11:17. This is one of the first big ones I caught here. So I'll just play this one more time, and then I've got another clip I want to show you of something different. So here it comes. And so these, I figure, they're about every 15 seconds. So there you go. That's your proof that you've got electromagnetic frequencies are quite literally caught on video. Now this one still ties into my whole point about how I was saying that the wind is almost coming up from the ground. It seems to me like everything is swirling around like this, you know? And it seems to be hitting the ground and coming right back up, if that's what's happening. I mean, I don't know. It might just be coming off the ground. I can't really explain what's going on here, but I can tell you that as I look at these palm trees here to the left of this hut, and I look at this little shrub here, I notice that this shrub doesn't take a bent form, even though there's water right here. This is right where the water is, and it should be pushing this thing right over. And what you're going to see is, although the wind starts increasing and this palm tree starts bending over a little bit, the shrub is still like shaking its arms up in the air about the exact same time this whole house shakes. You're going to get this whole part of the building shaking, and then the roof is going to pop right off. It happens very quickly. I'll play it for you once or twice so you can see what I'm talking about. Let's just watch this. See the shrub arms moving here? They're going to start moving faster as the next scene approaches. Now watch the building bounce and the roof come off. I'll play that again. They bounce and then off. So the shrubs are like waving their arms in the air. In other words, the current is coming from the bottom up. And the building responds in the same way. The building kind of does a bounce, and then the roof just piles right up and falls on the ground. So we'll just watch this one more time. Bounce and up. And it's strange because you would think that roof wouldn't just pop right off like that if the tree branches on here are not, I mean, these are hardly blowing. I mean, yes, let me put it this way. They're not blowing with the force or the direction that you would expect a roof to fall off. I would expect the roof to blow off like kind of in a diagonal, like it's being blown off the building, like it's being blown off to the side of the building. But this is quite literally coming directly up off the building and then flopping over. So it's as if there's another force that is being expelled from the ground area upward to thrust the branches of this shrub up, and the house bounces and the whole roof comes up. Let me just play this one more time for you. Actually, let me see if I can do this in slow motion. That might actually make it easier for you guys to see what I'm showing you. That roof just comes right up. See, just right up. And relative to what's happening with this tree branch here, the tree branches also are blowing right up. This whole thing doesn't make any sense. I mean, hurricane force winds should have a hurricane, tropical storm, whatever. They should come in a wall. They shouldn't be coming from the bottom of the ground and then blow up. They should be coming as a force that comes on to it, you know, like, yeah. So let's just watch this again. Okay, so hopefully you understand what I'm showing you there. Now, the next thing I want to show you about this video, it's kind of hard to show you. I did upload this video on VLC, but for some reason, VLC is not playing when I'm making a video anymore. So I can't do that. But what I was going to show you was this in inverted colors, because as this storm progresses, it gets very, very hard to see. But I want to show you this swirling pattern, you guys. I'm going to move my cursor up and back and forth in this video, and hopefully you'll be able to see. It is as if there is a swirling pattern right here, that we are looking into something that is not a hurricane that should be coming at the camera, but literally like as if the hurricane is looking into a swirl. And that's what we've seen in almost all these videos, where we have the trees being blown down but then pop right back up. As if there's a circle that's happening on the ground, like a mower, like those push mowers, like the blade of a push mower. Instead of a cyclone that's, you know, that's going at a 90-degree angle to it, it's as if it's as if there's something rolling over the ground. Completely different than what you would expect. It's going from the ground to the sky, to the ground to the sky, and in this swirl pattern. And so what I want you to look at here is how as I move my cursor across this camera, across this video, there are these striations here that intensify as the storm gets stronger. So it's as if we're watching the storm itself, the winds, the gusts of winds and the rain and everything go in the semicircle pattern, like as if the cyclone is on its side, like as if the cyclone is laying down or something. It's very bizarre. All right, let me show you what I'm talking about. Actually, I'm just going to drag this across. Hopefully you'll be able to see. See how it looks like it's swirling, like you're looking into the hurricane from the ground up, but actually we're just looking down the street. It's as if the hurricane or the tornado or whatever would be laying on the ground. You see that? Because it's swirling in a circle. Now, I'll just back this up and you should be able to see it in both directions. It's just crazy. I don't know. I can't explain what this is. It's like the force of the winds are doing exactly the opposite of what you would expect. They should be up and down, and it's, they should be going from left to right or in from, east to west, but instead they're going from ground to sky. You see what I'm saying there? All right, now another thing here is, and I don't know if that's electromagnetic frequencies that we're seeing, or if it's actually, it looks to me like it's actually the direction that the storm was going, because we have the trees that demonstrate that, and the wind, and the roof popping right off, and the rain and everything. So I don't know, something really messed up's happening here. And then finally, this is the icing on the cake right here. I mean, watch what happens on the horizon. Now this storm, people, this storm ended, at least in this area, it only took like an hour to go through. It didn't take even that long. I mean, by 1 o'clock, 1:30 in the afternoon, that thing was way to the north. And it was clear. It was clear right behind it. It was not a very wide storm, as we saw on radar. So what is going on here? Let's say this is 1 or 2 o'clock in the afternoon. What is this, a sunset? How on earth could this be the sunset? Because watch what happens in about 2 seconds. I'll play this all the way through to the end. Watch what happens. If this is the sunset, why does it rise? Watch this. I mean, that light doesn't even maintain its full circumference. I mean, it shrinks. Watch that. What is this? What's going on here? I mean, this is this is something to behold, people. We've got something very messed up happening here in this GoPro camera. So I'll just play this one more time, and you guys can see that these are electromagnetic frequencies in the atmosphere. What the heck are they doing there? If this is a normal hurricane, this is, what do people want to say? This is the sun rising and setting all in the same day? What's going on here, people? So I'm just showing you that we've got EMF signatures all over the storm, and it's obvious. This is obvious. This is not normal. This is totally not normal. And anybody who wants to argue it's normal is working for the enemy. So I just thought I'd share these things with you guys. There's a lot more to come. But this one's probably the most important one in terms of trying to figure out what's going on here. Share, if you guys come across these videos that you see these EMFs and you can see those those flashes and stuff, point them out to me and I will upload them. I think they're really important. All right, guys, thanks for watching. Have a good night. I'll bring you what I come up with as I come up with more. Bye-bye.